Welcome to Spring LIB.
Okay, the first part of the problem is very straightforward. You have to compute the work done, and that is equal to the change in gravitational potential energy of the cyclist, and that is just mass times gravitational acceleration times change in height, and mass is 75 kilo, g is 9.8 meters per second, and change in height is 125 meters. So you get 9.19 times 10 to the 4 joules, or about 92,000 joules for the work done. Part B is where it gets tricky. There's a lot of confusing words there, like tangential, tangential force, and complete revolution of the circular path, etc., etc. You have to know here that we have to invoke here that work done, again, will be equal to the change in potential energy, which will be mg delta y. This is not the same as the delta y in part A, okay, critical. And that will be equal to force times a distance, so call it x, okay? Just a dummy variable, x doesn't mean anything. And so for the tangential path, you have tangential force, F tan, that's what you're after, and x, so that's the definition of delta U, or definition of change in potential energy is basically it's it's a product of force and distance. And so the distance traveled here will be the circumference of the circumference of a circle, okay? And so that is the circumferential distance traveled in one revolution, circumferential distance of the wheels of the bike, and so that's 2 pi r is the circumference, and that is equal to mg delta y. And so let's write this down in another line here. Force, tangential force, what we're after, times 2 pi times radius of the wheel is equal to mass times acceleration due to gravity times the delta y, and that will be d sine theta, d being the distance traveled by the bike, or while the cycle completes one complete revolution. The 2 pi r is the one complete revolution part here, okay? So what we get here is tangential force is mg d sine theta over 2 pi r, and we know all these values, thankfully. M, again, 75 kilograms, g, again, 9.8 meters per second, d is 5.1 meters, and sine theta is sine 9.5 degrees. You divide that by 2 pi r, and so that's 2 pi times 0.18 meters for the radius of the wheel. And what you get is that tangential force, and the force we're after is 547 newtons. And that's it.